everyone, Namaskar. So today we are going to solve one more question, and this is from Fourier cosine transform. So we need to find the Fourier cosine transform of e power minus x square. Interesting one to solve. Let's start. So Fourier cosine transform of e power minus x square. So this will be somewhat a function of s, and Fourier cosine transform is given by 0 to infinity fx cos sx dx. Now let's take this as I, because we don't know directly as to how to solve this complex integral. Complex, that means difficult. So let's take this as equation number 1. Now what we can do, we can find di by ds. So only concentrate on terms containing s. So that will be 0 to infinity e power minus x square. Derivative of cos sx is minus sin sx. So minus sign I am writing here for some time only. Sin sx, and derivative of sx with respect to x, one x will come, dx. Now I will manipulate this integral a bit. So di by ds is, what I am doing is trying to generate the derivative of e power minus x square with e power minus x square. So how will I do that? If I multiply and divide by half, I will take minus sign inside. So multiplication by half and multiplication by 2 and division by half. So that minus sign and that 2 goes with x, and you also have e power minus x square, and you have sin sx and dx. So if I concentrate on derivative of e power minus x square, so that is e power minus x square, and with the help of chain rule, derivative of minus x square is minus 2x. So I can replace this by d of e power minus x square. Sin sx dx. Now I will obviously want to integrate the first one, because I know that integral of derivative is the function itself. So di by ds will be one by 2. Now sine first function as it is, I am taking this as the first function, this as the second function, or the opposite, this as the first function because I want to differentiate that, and this as the second. So first function sin sx as it is, and integration of derivative of e power minus x square will be e power minus x square only, I'm separating limit to both the terms. So this is 0 to infinity minus integral of derivative of first function. So derivative of sine is cos sx into s will come. So that s I am writing outside. Again, integration of d of e power minus x square, that will give me e power minus x square only. Now here, this thing if you see carefully, e power minus x square cos sx dx, that I assume to be I. So I am getting di. Again, if you see here in the first term, infinity if you put, so 1 upon e power infinity is 0, and the lower limit will become 0 because of sine. So this will give me 0, and this is minus s times I only. Okay. Now if I separate variables, so di by I is minus s ds. Similar question I have solved, so do watch that also. So log I minus s square by 2 plus log c. Now this log c can be moved to the left hand side, so that will give you log I minus log c, which is log I by c. I have skipped one step, equals to minus s square by 2. Now if you assume log base to be e, so I by c is equal to e power minus s square by 2. Now I is c e power minus s square by 2. Now if you want to find the value of constant, so put s equals to 0 on both sides. So you will have LHS I at s equals to 0, that we can calculate from the definition, and that is equal to e power 0 is 1, so this is c. I at s equals to 0 is, from the first equation, cos 0 is 1, so 0 to infinity e power minus x square. So I know 0 to infinity e power minus x square is straight away a standard integral, which gives me root pi by 2. So LHS you are getting root pi by 2, and that is equal to c. So that means c is under root pi by 2. So you got the value of your I, and which was what we required, because I was only your Fourier cosine transform of e power minus x square was only I, and that I came out to be c, which is root pi by 2. And this was e power minus s square by 2. I think this was the answer we were looking for. No, it is not correct. So let me check whether I have made it wrong. So I had this 1 by 2, which I missed in later step. So I hope that will make it correct. This was anyway becoming 0, so that will not impact us. Here you will get a s by 2, so you will get a s by 2 here, a s by 2 here, that will give me s square by 2 and another 2. So I will get s square by 4. Here also I will get s square by 4, s square by 4, s square by 4, and in the final result again I will get my it to be s square by 4. Now it's correct. So simple mistake made it very difficult to match with the original answer. Now it is fine. So again we have to find the Fourier cosine transform. Integrating was not easy, so we took this as I, differentiated with respect to s. Then we separated the variables, got the value of I was only a Fourier cosine transform. So I hope you understood this. For more such question, do watch my playlist on Fourier transform. That's it from my side. Thanks and have a nice day.